Today we're starting Unit 2, and our first lesson covers the first two sections in our textbook: patterns, inductive reasoning, and then the second section is conditional statements. So we'll start off by talking about two types of reasoning. If we reason based on patterns that we observe, that's known as inductive reasoning, based on patterns. And deductive reasoning is the process of reasoning logically from given statements or facts. And when we do proofs, this is what we are going to use: deductive reasoning. So inductive reasoning would be something of the sort, let's say you made a conjecture that your bus is going to arrive at your bus stop tomorrow at 6:55 because that's what time it has arrived every day this school year. We're basing that on a pattern that we've observed, so that's inductive reasoning. Deductive reasoning is the type of reasoning we do when we use logic. Okay, and I think I just used this term a minute ago. A conjecture is a conclusion you reach using inductive reasoning. A counterexample, and I'm pretty sure you should have made flashcards for all these words last night. A counterexample is an example that shows that a conjecture or conclusion is false. We'll talk much more about all these terms in a little bit. Well, here's an example. What is a counterexample for the conjectures below? A says if the name of the month starts with the letter J, then it is a summer month. Well, there's definitely a counterexample, right? January. January. Of course, June and July are summer months, and they do start with J, but January would be the counterexample. So we would say that this conjecture is false. If you can find one counterexample, your conjecture is false. Okay, and how about this one? You can connect any 3 points to form a triangle. Well, of course, this is false, right? Because we could have 3 collinear points, and we could not make a triangle out of those. So our counterexample would be 3 collinear points. So again, we have a false conjecture. We're very interested in this unit in whether things are true or false. Okay, what is a type of logical statement that has two parts, a hypothesis and a conclusion? That's called a conditional statement. A conditional statement. It's got an if part and a then part. The if part is of the conditional statement is the hypothesis. The part that comes after then is the conclusion. So let's go back up here. I think we had this one, A that we looked at up here. This is a conditional statement, right? Because it's got an if and a then. So what we know then is that everything after the if, not including the if, everything after the if is the hypothesis. I'm going to abbreviate that. And everything after the then is the conclusion. So you better remember this. The hypothesis comes after if, does not include if, and the conclusion comes after then, but does not include the word then. And then I copied this little box out of your textbook. It's right in there, and it tells you the kind of symbols that we use for conditional statements. We refer to the hypothesis as P, and we refer to the conclusion as Q. So if we want to talk about if P then Q, we write it like this. The way I would say that is if P then Q. P is your hypothesis, Q is your conclusion, and as you can see, we can represent this conditional statement with a Venn diagram, and the hypothesis will always be inside of the conclusion. If P is true, then Q is true. Okay? I promise, if you're confused now, you're going to get a lot of practice, and I think things will get really cleared up for you. So don't worry. Okay, here's another example. What are the hypothesis and conclusion of the conditional statement below? If an animal is a robin, then the animal is a bird. Well, the hypothesis is an animal is a robin. The conclusion is the animal is a bird. And of course, if we wanted to do a Venn diagram, we would have if an animal is a robin, I'm going to shorten it here, then it's a bird. So you see, I got birds that are not robins, but I don't have any robins that are not birds. So all the robins are contained in the birds, but of course you got sparrows, blue jays, all kinds of other birds that are not inside of our robin circle. All right, now we're going to talk about another new term, and it's called the truth value. The truth value of a conditional is either true or false. So you can have a conditional statement, it's either going to be true or it's going to be false. As I said a minute ago, if you can find even one and only one counterexample, then the truth value of the statement is false. Okay, so let's look at these and determine what their truth value is. If a number is divisible by 3, then it is odd. Is this true or false? It's false. How come? If I say it's false, then I need to provide a counterexample. So my counterexample could be 12, right? 12 is divisible by 3, and it's not odd, it's even. Okay? Why don't you pause here and see if you can figure out whether the next one is true or false? All right, we know that's true, right? It doesn't matter what the linear pair looks like. We know that if two angles form a linear pair, those two angles will always be supplements of each other. Okay, so let's talk about some other new terms. How about this one? The negation. The negation of a statement is the opposite of a statement. So the negation of yes would be not yes, or no, but typically when we negate something, we just put the word not in front of it. The symbol for negation is this. It looks just like that. It's like the little mark that's on top of the congruence symbol. And when we negate the hypothesis, oh, I'm sorry. Hold on here. I'm sorry, I wasn't reading my statement correctly. It says the symbol is what when we negate the hypothesis? Of course, it would be not P, and when we negate the conclusion, it would be not Q. So the negation of P is not P, and when you see that symbol, that's just read as not, and the negation of the conclusion is not Q. Okay, now, what kind of statement is formed by switching the hypothesis and conclusion? In other words, by doing this. You know our conditional statement, the conditional statement is if P, then Q, right? Well, if we switch these, we got if Q, then P, and that is the converse. The converse of the conditional is when we switch the hypothesis and conclusion. Okay, what happens if I negate the hypothesis and negate the conclusion? So what's that going to look like? It's going to look like if not P, then not Q. That's known as the inverse of the conditional. And finally, if I negate the hypothesis and conclusion of the converse, okay, so here's the converse. If I negate that, I'm going to have if not Q, then not P, and that's called the contrapositive. Contrapositive. When two statements are either both true or both false, they are called logically equivalent. And I'm going to tell you right now which ones of these four statements are logically equivalent. The conditional statement, let me just write it over here. The conditional statement is logically equivalent, that's what I'm using LE for, to the contrapositive. and the converse and inverse are logically equivalent. You got to remember that. Look at this little table that I printed from you here at the bottom, right here. You have to remember this. You better make yourself a flashcard and you better look at it many, many, many times. Okay, here's your symbology. Here's how to read it. Here's an example. Here's how to write it. This is a great table that you need to memorize as soon as you possibly can. All right, so let's do some more examples. I think that's probably all we got left. We got a lot of new terms in this unit, so you really, really got to practice those flashcards. Write the 3 statements below as conditional statements. Okay, I'll do a couple of these, and then, of course, I'm going to pause and let you do the rest of them. Conditional statements. 3 points are coplanar. Oh, it's already got an if, so I'm just going to say if 3 points. If I've already got an if in there, I'm going to use that as my hypothesis. If 3 points lie on the same plane, then they are coplanar. All right, so my hypothesis is 3 points lie on the same plane. The conclusion is they are coplanar. Could I have written it the other way? If 3 points are coplanar, then they lie on the same plane? Yes, that would have been true, but that's not always the case. Remember, the converse will not always be logically equivalent to the conditional, so you have to be very careful. If they give you the if, then that means this is your hypothesis, and you have to write your conditional statement that way. Okay, water freezes at temperatures below 32 degrees Fahrenheit. Okay, I'm going to say if water freezes, then it is below 32 degrees Fahrenheit. Right? Okay, number 3, an even number is divisible by 2. You pause and write that one. Okay, see what I have there for number 3? If a number is even, then it is divisible by 2. There is our conditional statement. Okay, some different types of examples. We have a conjecture that says if the sun is shining, then we are not watching TV. Remember what a conjecture is? It's a conditional statement made using inductive reasoning by patterns. Okay, so what would be the inverse of this? Remember, to get the inverse, we have to negate the hypothesis and the conclusion. So that would say, so this is P, the sun is shining, that's P. We are not watching TV is Q, so we're going to negate both of those, and it's going to read, if the sun is not shining, then we are watching TV. Right? Because if I negate something that's already negative, then 2 negatives make a positive, right? Okay, I want you to pause here, and I want you to try to do the rest of the problems on this page. Come back and check your answers. Okay, I think it's a good idea if you write the notation for the inverse and the converse and the contrapositive a few times so that you memorize it. And we have our conjecture here that if the sun is shining, then we are not watching TV. Okay, oh, I think I did the first one. I think I did the inverse. So let's go look at the converse. The converse, I just switched the hypothesis and conclusion, and so it would read, if we are not watching TV, then the sun is shining. And finally, the contrapositive, I have to negate the conclusion, and I have to negate the hypothesis, and then I switch them. So the contrapositive would say, if we are watching TV, then the sun is not shining. And remember which sets are logically equivalent. The conditional is logically equivalent to the contrapositive. The inverse is logically equivalent to the converse. And remember what logically equivalent means. It means they have the same truth value. And this is very important, guys. You better write yourself a note somewhere. It doesn't mean that they're necessarily both true, because the conjecture could be false as well. But if the conjecture is false, the contrapositive is false. If the inverse is false, the converse is false. So the two that are logically equivalent have the same truth value, whether it be true or false. Okay, and then finally for the conjecture below, you can see what I came up with there. Check your answer against it and make a note over here or down here somewhere if we need to talk about this in class tomorrow. Okay, and finally, I put up a couple of Venn diagrams, so I want you to pause here and I want you to try to do these, and then it says, hey, why don't you think of one or two of your own? So do that, come back and check. Okay, here we go. What I wrote for the first practice problem is, if a number is a whole number, then it is an integer. We know that to be true. That's saying every whole number is also an integer, but there are integers that are not whole numbers, right? The negative integers aren't whole numbers, so we know we got that one right. Okay, secondly, if a plant is wheat, then it is a grain, so everything that is wheat is also a grain. We have grains that are not wheat. We got rye, we got, I don't know what all, but plenty of grains that aren't wheat. But if it's wheat, it's a grain. And finally, the one I made up, I decided to write, if it is Friday, then I will wear a Woodson shirt to school. So as long as it's Friday, every Friday, right here, I'm going to wear a Woodson shirt to school. But if I'm out here, what is that saying? It's saying, well, it could be Wednesday, and I could also wear a Woodson shirt on Wednesday. This doesn't say I wear a Woodson shirt only on Friday. So this is an interesting one, and I look forward to seeing the ones that you made up, because we're going to talk about those and see if the converse is true, the inverse, and the contrapositive. So be sure to complete that, make your flashcards, and we'll see you next time.